We're going to look at bonding.
Oh, is this with the protons and the neutrons and the electrons? Oh, I think I lost mine.
We'll first look at ionic bonding. Does anyone know what ionic bonding is?
Something that bonds a type of atomic bonding.
It's when bonds between atoms are caused by the complete sharing of electrons. Where one atom completely gives up its electrons to another.
Yo, that teacher's scary.
I don't have my periodic table with me right now.
So a bond is a force that holds atoms together. It creates a compound with new properties which are different from the individual elements. Chemical bonds form because of attractions between oppositely charged atoms called ions. So we have the octet rule that we'll need to learn. Atoms bond because they're trying to achieve a stable electron configuration, like the noble gases. All atoms except for hydrogen and helium want 8 valence electrons. Hydrogen and helium is full when it gets 2 because its innermost energy level can only hold 2 electrons. So, let's look at a very common ionic bond. Table salt, NaCl. Is sodium a metal or non-metal? It's most definitely a metal. Look at it.
Is it Na1?
So, how many valence electrons does Na have?
I don't know.
So let's review. We've already done this before, but it's been a while. So, looking at periodic table, everything in this group has 1 valence electron. This is group 1A. Everything in this group, group 2A, has 2 valence electrons. This is 3A. Everything in 3A has 3 valence. This is 4A. Everything in 4A has how many? 4 valence. Then we have 5A, 6A, 7A. Then the noble gas is 8A. This has 5 valence. This has 6 valence. This has 7 valence. And all of these have 8 valence except for helium. How many does helium have? It only has 2 electrons. So both of those 2 are valence. Remember that helium looks like this. Has a nucleus and then 2 electrons. Whereas neon would have this inner level and then 8 on the second energy level. Because as we go down, we gain energy levels. So sodium is in this first group. It has 1 valence. It looks like this. We have an inner energy level with 2. Another energy level, since it's in the third group, it's going to have 3. It's going to have 8 here. And then it's going to have an outer one. The outer one is known as the valence. So it only has 1 in this valence. So recall that, that's physics, call that valence electrons are the electrons in the outermost shell, or outermost energy level. So, let's look at sodium. Sodium is going to look like this. It's going to have 3 energy levels because it's in row 3. The outer one is only going to have 1. So it wants its outer level. It wants its outer level to have exactly 8. How can it do this? How can it get 8 on the outer one? Gain how many? So it can gain 7. Is there any other way it can get a full outer shell that has 8? Lose 1. I hope y'all see that. So it can either gain 8. So it can gain, let me use, or gain 7, I mean. So it can gain 7. That's a lot of electrons to gain, right? Or it can lose 1. And when it loses 1, let's look at what it looks like. So it only has 1 in this outer level. It's lost it. Now it has 8 in its outer level now. Does everyone see that? It's lost this one, and all it's left with are these 2 energy levels. And the second energy level has 8. And again, for energy levels 2 plus, meaning more than 2, 8 means full. For energy level 1, so the first one, 2 means full. So let's look at lithium. Lithium is right above. It has how many electrons? So lithium has how many electrons? Same number as protons, 3. So the inner one can only hold 2, and the outer one's here. So again, it can do one of 2 things. So it wants to have a full outer shell. It can either gain 7. So, and become this. Or it can lose 1 and become this. Now we consider this one to be full even though it's 2 because the inner one's full at 2. What we're going to see is all of these metals, everything in this first group are all going to want to lose 1 electron. Now let's look at chlorine. So chlorine is over here at 17. It's in group 3. So group 3 tells us it has 3. 2 in the middle, 8 here. How many valence electrons does it have? 7. So it's missing this one right here. So it can either gain how many to get 8? 1. Or it can lose how many to get 8? 7. Which do you think is much easier? Gain 1. So notice this. Sodium likes to lose 1. Chlorine likes to gain 1. So sodium likes to lose 1, and chlorine likes to gain 1. Don't they make a perfect pair? This is the reason they bond together. This is why salt is made. These 2 elements are perfectly happy together. They are a perfect pair. So sodium is a metal. It has one valence electron. And it's asking about oxidation number. Oxidation number, I'll give you all a proper definition. We are going to ignore the proper definition. So oxidation number is the theoretical charge if we assume the bonds are all ionic, meaning electrons are completely given up. So it's the charge if it's ionic. So Na, we said, wants to lose an electron. So it's going to lose one electron, and it's going to thus gain a +1 oxidation number. So this makes it, we'd write it as Na, Na1 plus. But we often omit the ones in these, so we write it as Na plus. So oxidation numbers, the plus sign is before. For charges, the plus sign would be after.
So like 2 plus.
Yeah, so +2 is how we would write the oxidation number. But if an ion has a charge of 2 plus, so for example, magnesium 2 plus has a oxidation number of +2 and a charge of 2 plus. I'm not going to worry about this class, keeping that up. But if you learn it now and take chemistry, it would be helpful. So chlorine likes to gain an electron. Electrons are negative, so it's going to gain a negative charge. So its oxidation number is going to be -1. So it likes to make chlorine negative. Does salt have any charges as a compound? And keep your mask on. It's neutral. It's neutral because the two ions, Na plus and Cl negative, cancel each other out. So if we add 1 plus -1, so +1 plus a -1 equals 0. Thus, this overall charge is 0. We call these two things right here ions. Particularly, and rewrite it. The positive ion is called a cation, and the negative ion is called an anion. So this is a positive ion, and this is a negative ion. An ion is an atom or molecule with a charge. An ion is an atom or molecule that has a charge. How I remember these apart is, let's think of the number line. We have 0 in the middle, right? We have positive numbers on the right-hand side, and we have negative numbers on the left-hand side. Let's write these two things in alphabetical order. Which comes first, A or C? A. So A comes first, then C. Thus, A is on the left-hand side and is negative. C comes afterwards, which is on the right-hand side, positive. That's honestly how I remember it, is that if you sort these by alphabetical order, A comes before C, and negative numbers are first.
And if B is neutral.
I like the fact that this PowerPoint's wrong and they put the plus sign after. But again, it doesn't matter too much. So chlorine is a non-metal. It has seven valence electrons, and thus when it becomes an ion, it gets a 1 negative charge. And since it says ionic, we can assume charge is the same thing as oxidation number. So let's look at some common ionic compounds. Sodium chloride. This is table salt. Sodium bicarbonate, or baking soda. Its formula is NaHCO3. Sodium hydroxide, which is lye used in soap and drain cleaner. Potassium nitrate is a saltpeter used in fertilizer, gunpowder, and food preservatives. Magnesium sulfate, or Epsom salt. Potassium bromide is used to prevent epilepsy in dogs. Sodium fluoride is an ingredient in toothpaste used to prevent cavities. Calcium carbonate is found in rocks. It's limestone. Chalk and antacids are made out of calcium carbonate. So let's look at some properties of ionic compounds. So what would you think they're all called, classified as?
Like all of NaCl.
Mm-hmm.
Compounds.
They're all small crystals. They're actually labeled as salts. Mm-hmm. We just particularly call table salt just salt by itself. Just like gas, like gasoline, is not a single formula for anything, but we just collectively call it that. Or Kleenex for tissue paper, is a generic term, or when you're supposed to be referring to one thing. So they all have a formula unit. The formula unit is the single, like as low down as you can get, like NaCl. You can see some of them, you can have more than one. Like, doesn't have it, but like magnesium oxide would be, or I think sodium oxide would be Na2O. You'd have 2 sodium for every 1 oxygen. They're solids at room temperature. They dissolve easily in water and exhibit a crystal structure. They have extremely high melting points and boiling points. So let's before I get into actually figuring out whether or not something is ionic, based off the properties I said so far, we know that NaCl, or salt, table salt specifically, is ionic. Let's look at sugar. Is sugar ionic?
Yes.
Put your phone up.
Oh yes. Or sugar? Or what kind of sugar?
Any sugar. Is it ionic? John, look it up. So, is sugar crystals? So being a crystal, is a property of ionic. Let's see some more things. Is it a solid at room temperature?
Yes.
Alright. Does it dissolve easily in water?
Yes.
Oh, it's looking very ionic.
No, I know.
Does it have an extremely high melting point?
Yes.
You've never made caramel?
No.
You ever melted salt?
No. Salt.
You can take salt and put it in a fire, but not melt it. Have you ever burnt sugar?
No.
So, remember, I think it was y'all's class where we accidentally dropped. It immediately started melting and smoking. It's not ionic.
What sugar is that?
It's not ionic.
Is that West? God dang it. What do we get to eat these?
It's the people who made the highest are gonna get it, and I'm gonna over spring break. Is going to be I'm gonna let them dry out. I've been removing some of the liquid and letting them dry. So, well, if y'all would have came today and brought some flavor, like I said, so they're considered an electrolyte. So pure water doesn't conduct electricity. But if you put an ionic compound into water, it makes it able to conduct electricity. And that's what an electrolyte is. It's a compound that conducts electricity when dissolved in water. And this is the important one for this class. They have a high electronegative difference between the ions. So do y'all have y'all's periodic table?
Yeah.
And I'll get y'all a better one that has these values later. We'll look at the bottom ones for right now. There are a few mistakes on that when they put a letter D, and I think boron's off.
Oh, yeah.
So let's look at the EN. So these two, this is also more precise, but we'll use the bottom one for this class. You'll see that these numbers are way more precise. But let's look at sodium and chlorine. What is the difference between these numbers? So 3. Do y'all not know what the word difference means mathematically?
I thought you meant like the physical difference.
There's addition. What is the addition of two numbers? That means sum. What the difference is subtraction.
I was not thinking math. I didn't do it. I was thinking.
So 3 minus 0.9 is 2.1. That's a big difference. Considering the highest number is 4 and the lowest number is 0.7, that means is. So, ionic bonds are composed of cations and anions bonded together. Atoms actually bond according to their difference in electronegativity. Electronegativity is the ability to attract valence electrons. It's how strong you pull on another atom's electrons. The higher your electronegativity, the more stronger you pull. So if you look at a table of EN values, and I'm mostly going to be calling it EN for electronegativity, find the difference between two atoms. Subscripts do not affect calculation, so it doesn't matter if it's H2O. It doesn't matter, the 2 on the H doesn't matter. If the EN difference is greater than 1.7, It is called ionic. And this is a scale. It's fuzzy. It's not black and white. There's not like anything over 1.7 is 100% black and everything less than 1.7 is white. It's a grayscale.
So if it were to be 1.7.
So if it was 1.7, it's more ionic than anything else. So it's like looking at this row right here. It's the more higher you get, the more ionic you become. And we just arbitrarily said anything greater than 1.7 we will call ionic. Lift your head up. So we saw that the EM difference of NaCl is 2.1. 2.1 is greater than 1.7, so table salt is ionic. Let's do the famous chemical you might have heard. Water. What's its chemical formula? Is this ionic?
Yes. Shoot, I don't know. Ionic.
So, what's the properties of ionic? Is it a crystal?
Yes.
At room temperature? No.
1.47.
Does it have a high melting point?
Yes. It can't be done for me.
No, it's already melted. Is it a type of salt? No. It has none of the properties of ionic. But to really know whether it's not ionic, let's come over here. So, hydrogen has a 2.1. Oxygen has a 3.5. And have you never seen this Greek letter D? It looks like a triangle. This is called delta. It stands for difference or subtraction. So the difference in En would be equal to 3.5 minus 2.1, which is 1.4. Is this number greater than or less than 1.7? Less than 1.7. So not ionic.
Is there any exceptions? Like that's under 1.7, but it's still.
No. I mean, for the purpose of this class, no. Again, it's more of a scale. But later on we'll see. I in my higher level class where we go over like way more chemicals and go more in depth in this in true chemistry class. I haven't encountered any. And basically in that class all we do is exceptions. So lithium chloride. Lithium is 1.0, chlorine is 3.0, the difference is 2.0, this would be ionic. What about carbon dioxide, CO2? Ionic or not ionic?
Let's see. Not.
So, CO2. So, carbon is 2.5, oxygen is 3.5, the difference is 1.0, so not ionic. Magnesium oxide. Is it ionic or not ionic? So, magnesium is right here. It's 1.2. So, the difference between that and oxygen is 2.3. So, that'd make it ionic. Triboron. Diphosphide. Not ionic or ionic.
But what is boron is 2?
So boron is 2.
Oh, no, that is not ionic.
So the difference is 0.1. Very, very not ionic.
So if it's 1.7, then it's considered ionic.
Yes.
Okay.
Oh, no, it's greater than 1.7.
1.8 or
So, yeah, it has to be. So, 1.7 would be considered. I mean, by the definition they said, it would be not ionic.
Yeah.
But I would say greater than or equal to. If it's 1.7, it's around the limit. I'm not going to count off if you go either way. I would put it as ionic. But technically, the definition given on the PowerPoint, 1.7 would be considered not ionic. Because it uses a greater than symbol. Yeah. So, NF. Ooh, my pen's dying. So is that ionic?
Is there a question?
Yes. Is NF3 ionic or not ionic?
Not ionic.
So N is 3.0. Fluorine is 4.0. Fluorine is the highest. Fluorine is the most electronegative element. The difference is 1.0, not ionic. So let's look at the ionic ones. So we also had up here lithium chloride. That was ionic. We saw H2O is not ionic. We saw NaCl is ionic. So let's look at the ionic ones. What do all the ionic ones have? So this one is ionic. This one is ionic. Let me do another one. Na2 oxide. That would be ionic. What do they all have in common? They're a metal with a non-metal. And look at all the non-ionic ones. Where are they? Non-metals bonded together. Now this has many exceptions, but generally if you have a non-metal bonded with a non-metal, it's usually going to be not ionic. It's not always the case. For example, boron, which is non-metal, and fluorine, this would be considered ionic. Yes? So, ionic bonds occur when the valence electrons are transferred, completely given up, from one atom to another, usually between a metal and a non-metal. Cations donate, give, or lose electrons. They give up their electrons. Anions will accept, take, or gain electrons. Opposite charges make them attract or be bonded together via electrostatic forces. So, one thing we can do is write in Lewis dot notation. We'll learn that later. So this has 1 valence. This has 7 valence. Basically, Lewis dots, we put dots representing how many valence electrons it has. Whenever this one is going to want to give this one up and put it right here. So this is going to become positive. And when this one gains an electron, it becomes negative. Negative and positive charges, and Tamara, keep your mask on and your eyes open. Positive and negative charges attract. Brent, stop it. Positive and negative charges attract, so they're going to pull to each other. It's like having 2 magnets. It's like having a north magnet side of a magnet with a south side of a magnet. As long as they have different charges, they're going to pull and stick together. So what we're going to end up happening is have NaCl like this. They're going to stick together and form NaCl. So what is the charge of a sodium ion? Sodium wants to lose 1 electron and thus become positive.
So how come it didn't lose something?
Because it's losing a negative number. It's losing an electron. If you lose -1, so what is 10 minus -1? 11. 10 minus -1 is 11. It's higher up. Or 0 minus -1 is +1. Chlorine, it wants to gain an electron. It has 7 valence, so its charge is NaCl. Neutral. It has no charge. The overall charge of any ionically bond compound is 0. This means stability. Ions don't like to exist in nature. And that's it for the day.